So we got almost 60 people that have joined us this morning. That's fantastic. Okay, we had 90 people registered, which means another 30 are trying to figure out their computers. And I completely get it. Go get the grandkids. Go have them figure it out. They'll tell you exactly what to do in probably about 2 or 3 swipes of a finger, as is typical. So we're up to 60. I think we're going to go ahead and.
Well, wait. Let's wait a few more minutes, Jeff.
Yeah, sure.
Let's talk to.
There's Chris.
Get Larry to bomb in here. Turn your video on, Larry, and say hello to everybody. And then I'd also like to kind of do a hands up, Jeff, on the directors, but we'll do that after Larry talks to us.
Sounds good. Okay, Larry, I asked you to start your video.
I tried.
Okay.
Oh boy.
Is it working?
Nope.
Well, we can hear you.
Can hear you though.
Oh, it says it can't start the video camera. I don't know what I'm doing wrong.
All right, well, we can hear you. Go ahead and address everybody.
Oh, well, I wasn't prepared to say anything, but anyway.
Well, just say your normal welcome to the video, Larry.
Okay. Welcome to all of our members and visitors to our webinar highlighting coils today, tuning coils by Mike Kosser. So welcome everybody, and I hope you can all hear and see what's going on.
So Larry does not have video, but the rest of us do. And how this works, if you haven't attended a Zoom webinar before, is in the middle of your screen, about right here, you're going to see a chat. And if you click on that, then it should open up a new chat window. If you're on an iPad or an iPhone or another tablet, you should also have a chat control. You might have to swipe the screen or find a menu or tap on the screen and find that menu. And then there's also a button that says hand, raise hand, okay? We're gonna do a little test here. I want everybody to click on the raise hand button. Okay, there we go. Gary, Andrew, you got it, Robert. That's great, okay. That means that you can hear me. Good, so we only have a handful of people that are not raising their hand at this point. All right, about 10 people so far. So we got guests, and we've got Al, Dave, Jerome, okay? You guys see if you can find the raise your hand. Jim, Kathy, Larry, Peter, Terry, see if you can find raise your hand and raise your hand. Click on the raise hand button.
I know where it's supposed to be, but I don't see it.
Oh no, you're a panelist.
No, Larry, Larry, you can't do it because you're part of the panel. So panelists don't raise hands.
Oh, okay.
You can, if you wanted to open your attendee list, you should be able to see the attendees, Larry. You can see them all raising their hands.
We're at 64 at the moment.
So
4 panelists.
They can bop around and try and figure that out. I'm going to go ahead and lower everybody's hands.
Ask all the directors to raise their hand.
Okay, so if you're a director, go ahead and raise your hand, and you're on the call. So we got Jerry Kramer, Bill Bart, all right, Kathy, Keith, Steve Hughes. You're all raising your hands. Fantastic. You can have
me and Larry. So that's 7 of the 9 of us.
Yeah, that's right. You too. You're raising your hand, right? Virtually raise your hand.
Yeah, yeah.
There we go. Outstanding. All right. I'm going to lower all hands again. And so we got about 65 people, it looks like, that have attended. That's fantastic. You want to get started?
Yep, let's go. You ready, Mike?
Okay, a little bit of housekeeping here.
Yes, okay.
If you have questions, there's also a Q&A button that you can click on, or you can ask a question in the chat window, whichever you're more comfortable with. I'm going to say, hi, everyone, in the chat window. I just chatted to, whoops, that was just to the panelists. I'm going to send it to everybody as well. Hi, everyone. Okay, so all panelists and attendees. And so Chris and I are both here monitoring. If you type a question in the chat window and you have a question, we'll answer the question live. If you would like us and you have working video and you've done a Zoom meeting before and you know your microphone and your video work, at some point we'll ask you to raise your hand and we'll promote you here to a panelist, and you'll see your name and your video and your audio will actually be up here, and you can interact with us and our guests. So that added a little bit of spice to this in a little bit. I've done, I don't know, about 25 or 30 of these things at this point. So it's a lot of fun when you get participation. So with people come in and participate in your video and your audio works, it just makes it a lot more fun. So don't be shy definitely raise your hand. We'll get you up here. There's no stupid questions as we go through this. I know very, very little about the coils, so I'm super excited about this. And with that, Mike, I just asked you to start your video. You should have that going at this point.
Yeah, but you have screen sharing you have to enable for the presentation, not the video.
Well, either way.
Okay, I'll try to. It says host has disabled my screen sharing.
Okay, hang on. Let me do that now.
We did have a run through on this, Mike and I and Jeff on Wednesday, and we did do a little bit of practice, but we weren't in webinar host presentation mode.
Okay, very good. Mike, you're ready to roll, bud.
Okay, let me know if you see the screen.
Yep.
We do.
Go ahead and full screen it. Put it in slide mode.
We're going to go into presentation mode, and that's
Perfect.
This presentation is going to have animation in it, so we're going to want to view it in slide format. So welcome, everybody. Thanks so much for attending today and the opportunity to share information and knowledge on coil testing. And with that, this is my contact information and what we're going to be talking about. A little bit about me. I'm currently reside in Kenilworth, New Jersey. I've been interested in Model T since 2009. And we got our first Model T in 1927 touring in 2012 and having a lot of fun with that. Members of MTFCA and MTFCI. So on the coil tuning and testing webinar, the knowledge, information, tips, techniques, and that I'm going to present today come from many sources. One excellent source of information is the MTFCA forum, which hopefully most of you guys are involved with. And Chris and Jeff are both heavily involved as administrators. Greatly appreciate all that they do for that. Of course, the Vintage Ford magazine and Model T Times have great articles, technical articles for good information. And talking to and meeting with experts over the years from many very knowledgeable and experienced people on the forum, and got to meet them at Hershey and some club events. So a lot of wealth of information comes from there. Also formal education. My background in electrical engineering. I've also developed some products and tools for the hobby, which I find to work very well, and a lot of folks may know about. I want to mention that there are many other viable techniques and tools than I'm going to present today, and that they may work very well for you. So I want to acknowledge that. This is what I'm going to share with you today is really what I've learned and works well for me. It does not mean it's the only way to do things, obviously. Before we get started, calibration is required. What do I mean by that? Everybody's coming into this webinar with different knowledge of the topic that we're going to discuss, and this is the webinar people viewing here, so you're probably amongst here. And so what we need to do is try to get everybody on the same page with the terms and functions. Getting lost in the beginning or losing track of what's being discussed is no fun for anybody. I realize that that's going to be some new knowledge for some people and just a basic review for others, so I do appreciate your patience. I'm just going to pause them. Is my narration keeping up with the visuals?
Yes, it's good, Mike.
Okay, so first off, let's talk about the Model T ignition system. It's really a chain of functions that are all working together, and this is a list of them shown here graphically. Each element contributes to the result. All of these elements must be functioning well for good performance. You may have your coils adjusted just fine, but if you have an issue with the spark plugs or the wiring or the battery is weak, or it's not even electrical, it could be a carburation problem or valves or fuel. So in order to have good engine performance, we need all of these things working in concert. Today's focus is going to be on coils. We'll assume that that's the weak link. So let's talk about the Model T coil anatomy. I think most people are pretty familiar with that the coils have a primary and secondary winding, that there is an internal capacitor, some people call it, or early terminology was a condenser, and there's coil points. The fact is there's a whole bunch more of other details associated with the coil, and if you go underneath the surface, there's a whole bunch more of details that need to be, you need to be familiar with for the testing to be meaningful. So let's get in with a little bit brief introduction of it. So here is the depiction of the Model T ignition system. We have a source of power, which is the battery or the magneto. We need a source of activation, which of course is the timer, which is synchronized with the piston position. And its purpose is to deliver spark, which is going to be provided by the coils. And that spark's going to get delivered to the spark plugs at the right time. And when it occurs, then we have combustion and the engine runs and we're having a good time with touring. So let's get into the details of one coil and how one coil operates. Let's say at time 0, the timer moves on to contact. We'll start a clock at 0. If you look down in the lower left, we're going to start the current out of the battery and watch the arrows flowing up through the primary, through the points, and then into the timer to back to ground. That creates a magnetic field that starts building in the primary winding. That magnetic field, along with the black vertical bar in the middle of those coils over here, the core, creates a magnetic field which begins to pull down on the steel vibrator spring. You'll see the current starting to ramp up as that magnetic field is building. A little bit of time passes and the magnetic field gets strong enough to pull open the points. But the points don't fire a spark just yet, even though the points are open. Now, why is that? That's because the capacitor begins to charge, allowing current to bypass the points that are open and go through the capacitor. This happens for just a brief interval, and it allows the contacts to move physically apart so electrons can't jump across them and start arcing. Once the capacitor is fully charged, a little more time's passed, the current's flowed a little bit more, up to about 6 amps at this example, and the current stops flowing. When the current in the battery from the battery stops flowing in the primary winding, the magnetic field, and the points are still open, the magnetic field collapses. When the magnetic field collapses, that's when spark occurs at the spark plug. And we see that the current abruptly goes from about 6 amps down to 0 amps, and that's while running on 12-volt battery in this example. So this is the instant that spark fires at time 2. Okay, so current ramps up, gets about 6 amps. The points are open, the capacitor discharges or charges a little bit until the points are wide enough apart that the arc can't jump across them. The field collapses and we have spark. This whole process takes time. And during this time, what's happening? The engine's moving, it's turning, the piston position's changing with time. So the whole process is time sensitive, as we'll see as we get further. Now that's the theory, the way it's supposed to work. Well, let's look at a little bit more on what really happens when we're working with a set of simple contact points. The contacts open very fast. As soon as they open, the current is not quite high enough for a good hot spark because they open so quickly. And so what happens is a very weak spark is created immediately and early. The contacts close again because they open so fast, and then they open again, and it generates a second weak spark. This, of course, is the infamous double spark. And so why did that happen? We were supposed to fire spark here at 2 milliseconds. Instead, we fired one early and one late. That's not going to help us. So let's look at this a little bit more detail. What's the cause of double sparking? Moving contacts break with the fixed contact too fast. The coil current's too weak to produce a hot spark. The cycle repeats, generating a second weak spark. Double sparking is undesirable because the first spark is early and weak, too weak for reliable combustion, vulnerable to misfire. The second spark fires too late, and it's also weak, vulnerable to misfire. Double sparking causes ignition timing variation that's vulnerable to misfire. So we need some way for the contact points to remain closed longer to reach higher coil current and then break quickly. How are we going to do this? Some folks may know the answer to this, others may not. A big innovation was the KW points. and that was the solution to the double sparking problem. Anybody that's got early coil points or an earlier car with Kingston or the Heinz coils, those are the simple 2-element contacts we've just been talking about. Along comes KW, and they added to it a cushion spring and a moving contact. You can see that the contacts here are the contacts we've been talking about, but KW put the upper contact, not fixed, but on a movable spring. That's this dark orange, which is a movable contact. They've also added a limit rivet that will stop its travel at some point. So how does this all work? As the timer comes on contact and the coil starts ramping up current, the coil is activated by the timer. Current ramps up. You'll see that both contacts are still connected together and they're both accelerating towards the core. That's what these little red arrows are, that the magnetic field is pulling down the vibrator spring. But as it's pulling down the vibrator spring contact, the movable upper contact, which is the cushion spring contact, is following it. So there's been no break in coil current. The coil remains flowing and building up a higher and higher magnetic field with time as both of the elements are moving towards the core. The travel is only about 5 thousandths. Once the cushion spring reaches the limit rivet, it stops the cushion spring travel abruptly. The contacts open very fast, as you see here. Now, during the moment they open, the capacitor begins to charge, and it only does it for a very short period of time, millionths of a second. But since both contacts have been accelerated by the magnetic field and moving very rapidly towards the core, that brief interval that the capacitor charges is long enough for the vibrator spring contact to continue moving away. Once the capacitor is charged, the contacts are far enough apart that it's difficult for electrons to jump, and that suppresses the formation of an arc. And we'll see why that's so important in a little bit. The magnetic field collapses at this point and fires spark. KW cushion spring adjustment. So when you get a new set of points, we need to know how to deal with them. The cushion spring and set them up. So the cushion spring must have proper tension. If it has too little tension when you put it on, you see I opened the points, I pulled down the vibrator spring, and the cushion spring didn't move. So it can't follow the contact. It's not doing its job. I'll go back again. This is when it's closed. I'm going to open the points, and you'll notice the cushion spring didn't move. This is the result of double sparking, or this is the cause of double sparking we talked about in the way contacts theoretically work. And in practice, the vibrator spring pulls away so quick, it breaks the field, it collapses, it makes one weak spark early and then a weak spark late as it closes again. So we need to give it a little tension. However, you don't want to give it too much tension, because if the cushion spring has too much tension, when you go ahead and try to open the vibrator spring, it can't follow. Do you see why it can't follow? It's already at the limit rivet stop. So as soon as the magnetic field pulls this down, the cushion spring is restricted from following. So too much cushion spring tension is as bad as not enough. This too will double spark. And so you can easily check this when you look at your coils before you start adjusting anything. You want to make sure that you are seeing travel on the cushion spring from the rest position all the way up to when it comes down. You want to be able to see it move like that. If you don't, if you open the points and it stays there, you know you have too much cushion spring tension. Now, how do we change the cushion spring tension? Well, you put a little tool on the back here, and you can pry it up to increase the tension. And if it's got too much tension, you just give it a little pry down, it relieves it. So one thing that people familiar with coils know about as a common manufacturing issue is excessive cushion spring travel. The spec on the limit rivet is 5/1000ths from Ford. So the cushion spring is really only supposed to move from its rest position to the limit rivet head stop of about 5/1000. Due to manufacturing variation, you'll very often come across a typical set of points where that travels 15 to 25/1000ths. So what's the deal here? Why does that matter? This is a little illustration of excessive cushion spring travel. The points are closed and they're activated by the timer, the coil. So current's ramping up. Now, the magnetic field builds up and it opens the contacts before it hits the limit rivet. But when it does that, there's nothing to abruptly stop the cushion spring travel, and so the points open very slowly. And anybody that's done any stick welding knows that when you strike an arc and draw the electrode away from your work very slowly, that's what you're trying to do, is you want to create an arc and work with it. The capacitor here can't keep up with the very brief interval that the points open so slowly. And so what happens, that arc, just like in stick welding, begins and it causes the current to continue flowing in the coil. So no spark occurs. But you'll notice that now the current value, if you look at current on the left axis here, we got up to 6 amps as the contacts slowly open because the cushion spring hasn't hit the limit rivet yet. It draws an arc and it takes the coil current down from 6 amps down to about, in this case, 4 amps. Now the contacts get so far away that the arc cannot be sustained. The arc extinguishes and the coil fires spark here. So why is that a problem? The points open before the cushion spring ever reached the limit rivet. We generated a weak spark because current of the arc continued until it got to a lower value, and the spark energy is directly proportional to the amount of current flowing in the primary winding. So the lower current in the coil at the time of firing, the lower spark energy. We also have a secondary problem, is that we were supposed to fire a spark here along with all the other coils, but due to the arcing of the points, it delayed the firing considerably. So the piston now is much beyond top dead center. So just to summarize, cause of point arcing, the points open too slow before reaching the limit rivet head. The capacitor cannot keep the coil current flowing long enough for the point contacts to move physically apart, so we don't arc. The arc develops as the contacts move slowly, causing problems. One is that the energy of the spark is weaker because the current of the arc is allowed to continue flowing until it gets to a lower level. It delays the spark, it retards this timing. It also leads to premature contact wear. The arcing is actually causing metal migration from the contacts. And of course, inconsistent firing. Sometimes it arcs, sometimes it doesn't, which means sometimes the spark's delayed, sometimes it's not. And that's timing variation. You'll see an illustration here how this one was pretty much firing on time. This one arced a lot, this one arced a little. So you wonder why you just can't get your car running nice and smooth, and it's a bit of a mystery. Well, this could be one reason. Now, of course, how do we prevent point arcing? Well, that's pretty obvious. Fix the problem. What's the problem? Use a different set of points that don't have excessive cushion spring travel. A limit rivet that's only 5,000. Unfortunately, that can get costly and wasteful. You don't want to buy a set of points and then just throw them out. You could try to crimp the limit rivet to shorten its travel to about 5,000. You have to be careful doing that because there is a risk of over crimping it. Once you've over crimped that limit rivet and now it's only 2,000ths or 1,000ths, there's no way the cushion spring can travel and follow the vibrator spring contact long enough. So those points are pretty much useless unless you can drill out the rivet and replace it. they're going to be condemned to double sparking, just like you didn't have a rivet, a cushion spring travel. Another way is to try to compensate for the excessive cushion spring travel. The point contacts must remain closed all the way to the limit rivet, not 5 thousandths like Ford had intended, but now let's say we have a limit rivet that's 20 thousandths in length. You have to adjust a couple of the different variables, and all of the variables have to be adjusted just right. One of those variables is the point gap, which we start at 0.31. The cushion spring tension has to be just right, and the vibrator spring tension has to be just right. So the two contacts remain in contact and traveling towards the core for the excessive length that the cushion spring will now travel because of the longer limit rivet. It is doable, and in some coils, in some coil points, it comes right in. So there's no need to risk over crimping the limit rivet. Some, unfortunately, are pretty difficult. I've worked on some points for over, well, I don't want to admit it, but upwards of an hour, just trying to figure out why I can't get it firing consistent. And at that point, you may want to just shift to another one, put it aside. My recommendation is that you try the compensation method first, and trying to adjust those three variables, the point gap, cushion spring tension, and vibrator spring tension, to get good firing consistency. Once you've done that, if you can't do that, you just can't find a combination, you can try to attempt to change the limit rivet, crimp it, and I'll show you a method of doing that. So here's the compensation method. We have a large rivet cushion spring travel because the rivet's pretty long. All right, so you'll see the contacts are already open before it hit the limit rivet. They pulled away, causing arcing. They open slowly, creating the arc. We talked about that. The arc delays and weakens the spark, causing timing variation. You can compensate for the cushion spring tension by adjusting the cushion spring tension, as we discussed earlier, by either prying up or prying down. So how do we go about this? Adjust the vibrator spring tension for normal firing time. Didn't really cover this, but the vibrator spring tension is adjusted by tapping down on the vibrator spring, the tail of it right here. So you tap down to increase the upward force on pushing against the cushion spring, and you pry it up a little bit to decrease the tension pushing back on the cushion spring. So that's the other adjustment you can make, and you have to balance them. So here we want to try to find a sweet spot on the cushion spring. Not too much, not too little tension. We said too little tension may arc or double spark. Too much tension may arc or double spark. So we have to find the proper amount which will result in good firing consistency. If we're unable to achieve a balance of those variables between point gap, cushion spring tension, and vibrator spring tension, we may want to try to change the point gap. 0.31 thousandths is only a starting gap. You may want to close it up to 25 or even 20 thousandths, and then try to adjust the cushion spring tension and the vibrator spring tension just right. And we'll get into details on how to tune those variables in a little bit. If closing the points up doesn't work and you still can't find a balance between the variables, try opening up a little bit, and then try to find a balance between the three variables so you get consistent firing. And repeat those steps again. Adjust the cushion spring tension, the vibrator spring tension, and check your firing consistency. If you're still unable to find good to excellent firing consistency, carefully try to crimp the limit rivet to reduce the cushion spring travel to about 5 thousandths. And you'll find that you'll be able to come in much easier. Adjust the vibrator spring tension to normal firing time, and then adjust the cushion spring for good to excellent firing consistency. So these are the steps, and we'll go through them in a little more detail in a minute. So how do you go about reducing the cushion spring travel? Well, a few issues back, Mike Vaughn has documented a method that has been used that I found pretty successful, and that's in the January, February 18 Vintage Ford magazine. And basically what it does is it starts out with a piece of shim stock. I used 8/1000 because I wanted to leave a little safety margin. If you get down below 5/1000 of travel, you're kind of up the creek without being able to recover. The cushion spring travel is too short. So I cut a strip, a 2" by 0.4" strip of 8/1000 shim stock. Then in the step 2, take drill number 38 or a 0.101 diameter and drill a hole about 3/10 of an inch from the edge, as you see here. Then take a pair of metal shears and cut in from the edge to make a big U shape out of it. Now you can use the shim on a little anvil. You place the shim between the cushion spring and the upper bridge, as I'm showing here, and then you insert it all the way up until the circle of the drill hole is now right on the rivet. Next thing you do is you take a flat punch and tap down on it, and you sneak up on it until the shim is like a feeler gauge and gives a little bit of resistance coming out. I use 8/1000 shim stock, so if I get a little snug when I pull it out, I don't exceed the 5/1000. I tried this originally with brass, not a good idea because brass compresses, and I ruined a set of points. So I opted for some steel shim stock, and that seemed to do the trick. But again, I try to adjust the points for consistent firing without resorting to this. If you can get it to dial in, you're done. You don't have to worry about risking over crimping it. So now that we got the points, we understand the KW points, how they work, how to correct for, if necessary, the excessive limit rivet length. Let's just go through point geometry, because before you start doing any adjustment on coil points, you want to make sure you have proper point geometry. What does that mean? Usually you would start with the upper bridge parallel to the wood surface. The contacts should be aligned and mate squarely. You don't want them offset either front to back or left to right. So they should meet concentric, and the contacts must be closed at rest. They must be making good contact at rest. You'll notice that the cushion spring contact is all the way up too. It's not stuck against the limit rivet head. When you open the cushion spring, the vibrator spring contact and press it against the core, you set the adjusting nut here so that the gap is about 0.31. And this is just, as we talked about, it's just a starting gap. We may need to change that gap if we can't find a balance between the vibrator spring tension and the vibrator spring tension adjusted here and the cushion spring tension adjusted here, such that we get good firing consistency. So what does point geometry look like? Here's a set of points, and if you look carefully, you'll notice that they're not parallel. And as a result, you see how the contacts are only touching on the very little edge. So how do we correct for that? These upper standoffs were probably pressed into the wood from over tightening over the years. One trick, it was recently on the forum, and several people have talked about this in the past, is you take an old set of points and you clip the ears off them, and they make a couple of perfectly sized washers that you can now put underneath your standoffs, and that raises the back of the upper bridge. It makes them more parallel to the wood surface, and now the contacts are closing more squarely. You can also use 5mm washers that are available from various sources that work pretty well. So I'd say that pretty much completes calibration. We've been through the coil purpose, the coil components, coil operation, coil performance issues, and now we're ready to start talking about testing and adjusting. So congratulations, everybody. Everybody's educated to the same point, or at least hopefully. So what's the plan? We need a test plan. We'll first start out by checking the capacitor, because if the capacitor is not good and the points are arcing, or if the capacitor has a low value, the coil may not even fire reliably. So you need a good capacitor to start. We'll replace the capacitor if necessary, and I'm not going to cover that in this video. There are videos online on how to go about doing that. It's quite a messy job and one that you have to take good care on. Next, we're going to check the coil firing time and consistency and see if it's not broke, don't fix it. If adjustment is necessary, then we're going to cover on how to go about doing it. We're going to check the coil point contacts for wear. We're going to try to resurface the contacts if it's possible, because nobody wants to shell out the money for a new set of points if you don't need to. And unfortunately, some points are just so badly worn that we may need to replace them. Once we get the point contacts and the points wear assessed, we need to adjust them and make sure we have proper point geometry. And then the last thing is we want to adjust all 4 coils for equal and consistent firing time. So the first thing we're going to do is check the capacitor. To do that, we want to look at a few things. Most critical parameter is the value. The capacitor value should be 0.047 microfarads plus or minus 20%. It means it should fall in the range of like 0.37 to 0.56. That's the most important thing. There's also a term called leakage, and that is that the capacitor can't store charge for any length of time if the leakage is excessive. Now, generally, a capacitor has infinite leakage or very, very high value, typically 50 megohms or greater, 50 million ohms. In reality, the capacitor leakage, if it's even a million ohms, is not going to change how long it's going to be able to charge for to suppress arcing. So it's of less of concern. There's multiple sources of leakage that aren't even from the capacitor when it's installed. For instance, when you're testing it, you have to open the points to expose the capacitor, because remember, the capacitor is installed across the points. When the points are closed, the capacitor is shorted out by the points. So if you want to test the capacitor with the points closed, it's a short circuit. You have to open the points to expose the capacitor, and then you can measure its value. If your fingers are touching both point elements that the capacitor is connected across while you're measuring it, your fingers will allow current flow through and it'll be detected as leakage. The vibrator spring touching the core is another source of leakage, because the wiring insulation can have a tiny amount of leakage also. And sometimes that shows up. And there's also cases which I've come across is that somebody had painted the top surface of the coil with a black paint that contained carbon. Carbon is a conductive material, so there was like a megohm of leakage. Wasn't a problem being that high, but it did get picked up as on leakage on my tester. Unless it's very bad. If it's so bad, it'll usually skew the value of capacitance. There's no need to replace the capacitor if the value is in spec, 0.47 plus or minus 20%. If the value is low, like 0.05, 0.1 microfarads, 0.22 microfarads, if it is low, it should be replaced. And you have to replace it with the proper type. And there's more than just the voltage rating of 400 volts. You might find a capacitor with a higher voltage rating here, but there's another rating which is not listed on most capacitors because it's a specialized application, and that's called the DVDT rating, which really comes down to how much current the internal current the capacitor can handle. And you want to find one that has at least 600 volts per microsecond. And the Model T parts vendors typically will have in stock the proper one, so you don't have to try to find the type of cap on your own. If you do search a parts vendor outside, this is a rating you'll need to be concerned about. So on the capacitor test, I'm going to use the ECCT coil tester, which is an instrument I developed for testing coils. And to do that, you put the coil in the tester, you select the capacitor test, and then press the test button. And what that does is it measures the capacitance and displays it on the lower scale of capacitance microfarads. In this case, it's 0.47 microfarads, and the leakage is very low, so the Exxon light comes on. So this capacitor is good. Now, here's an example of what happens if you're picking up leakage, say from your fingers or the insulation resistance is poor, or the vibrator spring may be touching the core. The value is right on the money, but the pour light's on. So that's a quandary. Do we need to replace the capacitor in this instance? No, because if you had looked at the value, you'll see that the leakage is very high, 4 million, almost 5 million ohms. It's not a problem. The value is pretty much right on the money. So is it okay to proceed with coil testing with this coil? The answer is yes. So back to our test plan. We checked the capacitor. We found it to be the proper value. We're going to check the firing time and consistency. Do we need to adjust this coil? Let's talk about how we're going to test the coil for time and for firing time and consistency. We want to measure how long it takes the coil to fire a spark. We're going to start a watch or a clock when the timer comes on contact. When the spark actually fires, we're going to stop the clock and we're going to measure how long that takes. And the plan is we set all 4 coils to take the same amount of time. So that way we'll have better firing or ignition consistency and timing consistency. That's all done automatically by the ECCT. You press the test button, it starts a clock. When the spark fires, it stops the clock and displays time on the scale. But how does it display time? If it said that it fired in 2 milliseconds, would that be meaningful? So it's not. And so how do we get around to something that's more meaningful? Time will be calibrated in degrees of crankshaft rotation, assuming the engine's running at 1,000 RPM. So now you can get a sense that if 0 time is at TDC, that's actually about 2 milliseconds. So if it fires earlier than 2 milliseconds, it'll show up as 4, 3, 2, or 1 degrees negative or early. And if it fires late, it'll show positive timing error of 1, 2, 3, or 4 degrees after top dead center. Now, if we were going at 2,000 RPM towards the upper range of the typical operation, you would double these values. So that would be 2, 4, 6, or 8 degrees after top dead center. But for reference, we're just going to use time in degrees of crankshaft rotation, assuming 1,000 RPM, which is a mid to low level speed, just above idle. So the coil firing consistency test. We drop the coil in the tester, select the multi-spark test down here, press the test button. What the tester does is it's going to fire 100 sparks, and it keeps track of every single one of those sparks when it fired. And then it just gives you a display. Now the rules for lighting a light is 5 firings in any of these timing locations will light a light. Okay, so you see that it's distributed over 4 different times. 3. So you could see that it says that the result's poor because you have inconsistent firing and it's firing mostly late. But we don't know the distribution from the front panel. There's ways, there's rules that tell you again when it gets down to the middle LEDs of how many fired. There's also a way of displaying numerically and graphically this result, and what this would look like. And here you can see a little more information, which makes it a little easier to understand what's going on. Less than half the firings occurred at 0, and about 20% out of the 100 fired at +1. You got a little over maybe 12% at 2, and about 15% at 3. So we got a lot of variation on here. So does it warrant, it requires the result poor, and from the display, we realized it warrants adjustment. So adjustment is necessary. The plan is to check the point contact for wear, resurface the contacts if possible. So it depends how long this coil's been in service. Usually it's a friend's coil, or it's your coil that's been in the car for a while. So rather than just try to adjust it and have a tough time adjusting it because the contacts are worn or dirty, it's a good idea to pull those points off and inspect them. So we're going to remove the coil points and inspect it and resurface the contacts if possible. Let's take a look at this example. You got the vibrator spring contact on the left, doesn't look too bad. The cushion spring contact on the right over here looks a bit more. You can see there's a lot of residue that's built up on there. And you can see as the two contacts fire that there's a bit of a dusting that occurs around here from the firing that builds up. We want to clean that all off, and I will use a little contact cleaner or some alcohol. We want to remove that residue, and it could be a rather hard residue, and these are tungsten points. So how are we going to go about doing it? If they were badly worn or pitted, holes in it, or you see little deposits of metal on there on one surface that was removed from another, you want to really check your capacitor again, or maybe it was from a cap that was failing on one and continued to degrade, and you'd want to replace the badly worn points rather than try to reuse them. In this case, since they're not too bad, we're going to try to resurface them. An effective tool for resurfacing the tungsten contacts is a diamond hone. You can get them on Amazon and a very reasonable price. And the way it's used is you position it square to the contacts. It would be better if you used a fixture. I have it on my to-do list to put this hone in a fixture that moves with a 90-degree orientation to the contacts. And then you just clean them up as you would normally file them, gently, a little at a time. And then you can see that you can get a pretty good job at removing the residue. You'll notice that there is a small pit that did remain, and that is a little deeper into the surface. So I stopped at that point. Next time I'm probably gonna have to replace these points. But this way I have a nice clean contact now with a smooth surface. So assuming we could not save the points by cleaning them up, we would have to replace them. So let's just run through what we would do with new point preparation. When you take new points out of the package, they may have some oil for manufacturing on them. They also may have a clear protective coating on the point contacts. They might look good, nice and shiny, but when they close, they make no electrical contact, no coil current flows at all, and you're scratching your head why. You could rinse the new points in a lacquer thinner to remove the oil residue. The lacquer thinner may or may not remove the protective coating on the contacts. So what I use is a very fine sandpaper, maybe 600 grit, to remove the protective coating, just to scuff the surface. If you forget to do that and you have them on properly aligned, mounted to your coil, but you go ahead to test them and they're not firing, the points are closed, you probably have that protective coating still on there. So I cut a small piece of 600 grit paper, about 3/10 of an inch wide, 4/10 of an inch wide. I'll put it between the points, let the pressure of the points push on the paper against one another, draw it back and forth several times, flip it over and do the other side. And then if you do that and you find that the contacts are now clean, closed, but no current's flowing, why isn't it sparking? Be sure that you clean the point contacts after you sand them. The sanding residue could leave non-conductive debris and dust on the surface, which prevents them from really closing. So what I'll do is I'll cut a thin piece of paper and I'll soak it with some alcohol or electrical points and then drag it through the points until it comes out clean. Then of course you want to let the points dry before you use them, because you don't want to open the points and see a bit of moisture in between them from the cleaner. All right, so we got down to a new set of points, either resurfaced or a new set of points installed. Next thing is we want to do is check the point geometry, because we're putting the points back onto the coil. This is a review from before. We want to make sure the upper bridge is parallel to the lower bridge surface, shim it if necessary. We want to make sure the contacts are aligned, mated squarely, and they're closed at rest. Okay, we want to make sure the nuts, the mounting nuts for the standoffs are snug, and we want to make sure that the nuts for the vibrator spring mounts are also snug. It's important to make sure that after checking the gap at 031 that you tighten a lock nut. If you do not have a lock nut, and there's any play in the threads or the wear of this connection here, this could cause some variability in your timing. So I recommend using a lock nut and securing it once you've set the gap. All right, here we're checking the gap for 031. So once we got the point geometry in place, the next step is let's adjust all 4 coils for equal and consistent firing time. So here's the coil dwell time test to see if it's firing early. In that case, we're going to use the coil dwell test, and this is the stopwatch test. We press the test button, and it fires a spark. It starts the clock. When it fires, it stops the clock and shows you that this one's firing early. When it fires early, 2 degrees before top dead center, take out our little coil adjusting hammer, tap down on the rear vibrator spring here a little bit, and you'll see it says tap down here. That'll send this closer to the center by increasing the vibrator spring tension. If we overshot and tap down too hard, and I might caution you that tapping on the coil, I'm doing it right in the tester here because it's very gently tapped down. Small taps make a big difference. When you have a new set of points, this tends to be all the way over here. It has no tension, and you need to give it some good whacks to get down. And to do that, I grab the coil where the exposed cutaway is here, so harder strikes don't get transferred to the tester. And that way you can give harder whacks to the coil without having to endanger putting any stress on the tester. If you overshot and hit it down too far, you want to just pry that up gently. And tiny little bits of force make big differences, as you come to find with experience. It also has a little reminder here to pry up to get it from this side to back to the center, top dead center. Once you get it down to there, you may find that you're getting a double spark occurring, and that's displayed by 2 LEDs lit. Here it fired early and weak, and here it fired late and weak. And so the problem with that is the cushion spring contacts pulling away from the vibrator spring contact, or I should say it the other way around. The vibrator spring contact's pulling away from the cushion spring contact too fast. It opens and closed, opens and closed. So that's typically not enough tension on the vibrators, on the cushion spring. We know that it could be too much tension, and so one of the things you could do is take a look at the tester and the coil points very closely and make sure as you open the vibrator spring, the cushion spring is following it. If it's stuck against the limit rivet, it's got too much tension. If you open the vibrator spring and the cushion spring stays all the way up at the upper bridge and never follows it, you know it's got not enough tension. So if you need to adjust the tension to make sure that the cushion spring contact follows the vibrator spring contact as you're opening the points, you just put the little tool on the back and you bend it up a little bit, and that puts a little bit more downward force on the cushion spring. You can then again open the vibrator spring and watch it follow. Once you see it following, you can put it back in the tester and hit the test button on the coil dwell, and you should only see 1 LED lit for this single spark test. Once you have it firing in the center and only 1 spark, we want to check the firing consistency. So we go on to the multi-spark test. This is the test that will fire 100 sparks, keeping track of each one of them. So once it's on the multi-spark test, you press the test button, it fires them. And in this case, we know that at least 85% fired at 0 because the excellent light's on. If less than 85% followed it here, you would see, and therefore it would be good. Over here is an example of that. We have 3 LEDs on, and you know that at least 85% fired here. Otherwise, or we know less than 85% because the excellent light would have been on. And so you know that you're 0 plus or minus 1, which is still good. And remember, we talked about there's a whole chain of functions that have to be working in concert: the timer, the wiring, the contacts, the carburetor. The timer has to be concentric on the camshaft. There's a whole bunch, and the timer has to be clean, have good clean contacts and no bounce on the contact. Chances are, if you have other variables contributing to your overall ignition timing quality, having the difference between good to excellent may or may not be noticeable at all. If you have an engine that has all of those other variables very well maintained, you have a new timer and perfectly centered on the camshaft with new plugs and properly gapped or clean plugs. And so all those other variables in the chain are doing exactly what they should do. then you may see a little bit of a difference by trying to get the little bit of variation here down to an excellent condition of all firing, or 85% or more at 0. So it depends if you'll see any difference by spending the extra time to go from good to excellent, depending upon the other variables. Okay, so that's the idea. And here's a graphical display of the distribution. I think we saw this before. In this case, this is an example of the ones with the 3 LEDs on, where you see about 73% are firing right at 0, and the others between 10 and 15% are firing within 1 degree. So this would be good. The other thing you can do if you have the control panel is you can change the number of sparks fired, and you can change the firing rate. If you were going to have a more higher RPMs and you wanted to make sure it's not breaking up with a higher speed, you can change that up to 5,000. Of course, nobody's going to be operating quite that high. At least I don't want to be too close to that engine. So let's see. We talked about coil testing challenges and arcing. What's the advantage of measuring and testing coils by firing time, dwell time to fire, as opposed to the legacy coil current? This will just give you an indication of what the difference is in the differential. The contact arcing occurs randomly and it averages over time. So it may be difficult to detect when there's the presence of occasional arcing going on by monitoring the average current. For instance, here's an illustration. The reading here may be set to its nominal value by firing at a lower current that may fire that or close to that half the time, but it arcs at various points the other half the time, and that would be timing variation. And you might not be able to pick that up by just looking at the current. Now, this is not double sparking. It's only one spark, but it occurs at different points of time because the vibrator spring and cushion spring may not have the right tension, and you have a long limit rivet. So if you don't have it set right and the limit rivet exceeds that 5 thousandths, you can get yourself in a situation or experience a situation where the spark occurs mainly where you want it, but it varies in time. And you compensate for that overall by setting it a lower current that fires for a longer time. That's opposed to the case that fires all at the same time and the average value is the same number. And of course, this is the desirable one because that's the higher current, it's the higher spark energy, and it fires at the same time. So the contrast, you look at time here of when it fired and you get a distribution. You look at time here and you don't have a distribution. So this gives you a clear indication of firing, or it's a benefit of looking at firing time as opposed to coil current. Here are some resources that I find helpful. Coil points hardware, and I don't have the capacitor here, but the capacitor is also available from ModelTFord.com. Amazon is a good source for the Diamond Hone. Just search for Easy Lap Diamond Hone, and you'll get a whole bunch of different options. You can opt for a set of 3 of them, actually, for like $14. Coarse, medium, fine. And that works out very well for cleaning up points. Now, McMaster is the source of hardware some of you folks may be familiar with. These are the part numbers from McMaster for a black fiber step washer, which is used for the to center the upper bridge on the height adjusting nut. And it's stepped, and it fits right in the coil point hole very nicely. There's also stainless steel washers of 5mm or brass washers for the standoff shim. So if you don't want to use the ears, or the ears are too thick, and you maybe have a situation where the ears are so thick it pushes it up from too low to too high. You can get different thickness washers from McMaster. Here's 2 examples. One's a stainless steel and one's a brass, depending upon the type of standoff you have. And then here's some 1032 hardware for the nuts that are available either in steel or brass. The limit the rivet crimp tool, you might want to get together with some of your friends to get this, because I think the smallest amount of 8mm shim they have is 6 inches by 100. So you have to get a plentiful supply to make a little one. The toil tester is the website, and the different options you can get with that. Here's coil resources, some videos I made that show some illustrations of how to use the tester for with and without the software, with the how to adjust the capacitor, and also there's a magneto test option, which we can talk about that it has, and there's a video on how to use that. So in review, Model T coil system was looked at. We looked at the function of the coil. We reviewed coil components. We discussed coil operation. We discussed point evolution, the KW points, and the addition of the cushion spring, movable contact. Capacitor testing we covered, coil testing. We looked at coil point adjustment, the point gap, cushion spring tension, vibrator spring tension, the balance between them, and common coil issues and adjustment. Questions and comments?
Okay, guys, now's your chance.
That was great, Mike. Very helpful.
Before we do that, I just want to, I don't want to miss this screen. I want to just thank everybody for viewing. And I wanted to also give special thanks to the folks that helped set up and make this webinar possible. And that's our administrators, Jeff and Chris, Larry, our president for the MTFCA, Jerry Kramer, one of the board of directors, and the other MTFCA board of directors for making this all possible. Also had some help in viewing, editing these slides so that it went curiously error-free, and that wasn't by accident, to the thanks of Garrett Green, Gene, for others, and they didn't let me get too far with telling fibs. And a very important thing.
I've got a couple of questions here. Will the PowerPoint also be able be available for download? So we can certainly make that available. I'm also recording this webinar, and I'll be posting it to YouTube, and then I'll put a link in the webinar section of the forum, so you'll be able to find this in the future.
If you enjoyed the webinar, have to plug the MTFCA here. If you're not already a member, you might want to consider to help these to continue for the future.
Exactly. These the website and everything costs money, although it's a small portion of your dues. Everything helps, and the more members we have, the better. John Trout put up his hand, so I let you speak, John, if you have a question.
Yeah, not a question, more of a comment. I want to thank Mike for this and also thank MTFCA for doing this. This was terrific. I've been adjusting coils for a while, but I learned some really good stuff today. So thank you to everybody.
Okay, you're welcome. One thing I just throw this in before someone else asks a question is I've seen those videos of Mike's on YouTube, and those links that will be available are highly recommended. You can go and have a look at those, and he has it broken down at the various functions. So I can highly recommend those. I watched those last week.
Does anybody else have any questions? We got a question here from Paul Duncan. Unmuted you, Paul. Go ahead and ask your question. Well, I tried to unmute you. Nope, doesn't look like Paul's able to get his
Mike Koser, can you open up the question and answer box there, and maybe you can just jump in?
Sure.
So, Paul figured it out. So Paul, what's your question?
The question is that the ultimate, the main thing is when the engine is running, our ears are the ultimate test about how these cars are running, regardless of all the tests you've done, which on the coils, which is great. And I would suggest there's some people in our club, like Larry Azevedo, Vern Willen, who hear things nobody else hears. And I'm going to suggest that we begin to, on top of a discussion of the coils like you've done, have some recordings about what engines sound like and what the issues are with the timing.
Well, I guess that's a case by case basis. As we looked at in the very beginning, we started out about the chain of the whole chain of the functions that are going together. Certainly, valves and other functions have to be operating properly too. So it's certainly possible that you could pick up other issues going on.
Okay, Mike, there's a question on the Q&A. It says, what is the max voltage from the coil to the spark plug? And then it looks like a guess in parentheses, 22,000.
Well, that's certainly within the realm. It could be anywhere between like 12,000 to 20,000. There's a lot of variables that go into play with that.
Okay. What's another one? How much of a concern do you have on peak current? Is there much difference if you have 3 at 6 amps and 1 at 4 amps?
Well, the one thing I can say about peak current is the current is directly proportional to the spark energy. And there's a formula that you can apply to it. And so that it's actually to the square of current. So the spark energy is 1/2 Li squared. So I is squared. So the more the current, the more the energy to the square of the current. So current is the dominant factor as far as spark energy is concerned.
So would the car run any differently if 3 had 6 and 1 had 4 and it was still timed, doing the timing thing right?
I would say that you would not find, you would not likely perceive a difference unless there was a combustion issue, because the one with the higher spark energy is less likely to misfire.
Okay. How is that, Matt, in California?
Yeah, I want to mention that Matt has he's got an interesting tester that he put together out of a little single chip computer called an Arduino. And there's a discussion going on in the forums right now that I've been following. There's over 200 and several hundred posts about some guys going through the process of creating one of these testers. And it's just fascinating, the information that's being discovered and being discussed on that forum. So if you haven't seen that and you're interested in this, check it out for sure.
Okay, Mike, here's another question. Is there any difference between wood top and brass top coils?
I guess that's more of a question on evolution on how it came out. As far as functionality goes, they serve the same function. The mechanics of how they insulate from the brass, that I'm not that familiar with. But as far as functionality goes, I don't think that they serve the same basic function essentially.
Yeah. Okay. All right. That's all the questions we got. What do we got? Chats open here. Holy smokes. What is the difference in the excitation voltage applied by the ECCT as compared to either a 12-volt battery or the roughly triagonal signal from the magneto?
So the ECCT applies a 12-volt very fast pulse. And it's a bit of a compromise because the magneto puts out a voltage which is proportional to engine speed. So the faster the engine RPM, the higher the voltage. Now the pulse coming out of the magneto is either positive or negative. So you get both of them. The ECCT is designed just to mimic a very fast pulse from the magneto, but a positive pulse. And so it's measuring the response of the coil points starting from rest, just like they would be doing in your car when the timer's not on contact to when the timer comes on contact. And so that's what the purpose is, to mimic as close as possible it's kind of a little bit of a compromise as far as, because it's DC mimicking a very fast AC pulse.
Okay.
So we've got Jim Bodkin, who has requested his hand up. I'm trying to unmute you, Jim. Maybe you should turn your mic on. And then who else?
I killed a couple there. I thought they'd already talked.
No. There is Jim.
Is this working? Okay. Excellent webinar, Mike. Really good. Just, you make most of your adjustments by adjusting the cushion spring tension and the vibrator spring tension. What about, and you just use the upper spring adjusting nut to adjust the contact gap. Can't you make some changes in the timing by adjusting that nut simply?
Absolutely. I mean, all three of those variables are the key variables that you would adjust to get the proper firing time and the firing consistency. And so, if you have excessive limit rivet travel, it tends to be more difficult to find the balance, because now those two contacts are traveling together for a very long time before they hit the limit rivet. Obviously, they have to travel slower, and they have to remain together to travel longer. In the same time, it takes cushions, a set of points with a limit rivet of only 5 thousandths. It's going to be traveling, hitting that faster, and then opening. So there's a little bit of a difference in the balance of those variables that you have to get in order for both to have consistent firing and firing at the same time. Does that make sense?
Yes, I just find that I've done a lot of my adjusting simply by adjusting that nut, and it seems to have worked.
Yes, and that's the amount of travel that the two contacts will have to go. It adjusts the amount of magnetic pull right on the vibrator spring. And usually if you turn the nut counterclockwise, it takes longer to open. If you turn it clockwise, it opens quicker. So you can adjust the timing by adjusting the nut, but you'll also find that the effect of the cushion spring tension and vibrator spring tension will also change. The other thing I didn't mention is that as you adjust the vibrator spring tension to get it to fire at the right time, and then adjust the cushion spring tension to get the consistency improved, you'll note that the firing time shifts. So there's interaction between the two when you're adjusting the vibrator spring tension and the cushion spring tension. It's an iterative process.
Okay, thank you very much.
Yeah, and that's a good point. The 31 thousandths is merely a starting point gap. You may find by just changing that gap that the balance between the cushion spring tension and the vibrator spring tension, that you'll find a consistent operating consistency by just changing the nut, as you found. The height of the opening of the points, the gap.
Hey, Jeff, we got 3 more questions here. If we push answer live, do they pop in the box there and we, no, that doesn't happen. So the first question here, Mike, is what 2 contacts do you test the windings with? And what's the ohm value?
Well, you could measure the primary winding with an ohm meter. You can get them at Harbor Freight, a multimeter, and on ohms. And the primary winding is very low, and that's measured between the base power terminal and the upper contact closest to the contact points. And you'll measure when the points are closed to be about a half an ohm, 0.5. If you just touch the meter leads together, you'll probably get almost the same reading, because they're not very good at measuring low resistances. If you measure an open, you have a problem with the points. Very rarely do the primary windings fail. Sometimes connections to the terminals fail. Now, for the secondary winding, that is measured between the 2 side contacts, and that will typically measure 3,200 ohms. If that's open, you have a problem with your secondary winding.
All right, that's good. And the next from John again is, Mike, what are your +1 or +2 timing degrees in milliseconds?
That depends. You can equate to that by first looking at crankshaft degrees of rotation. And I believe that the way it works is that 6 times the RPM is the degrees per second. So 6 times 1,000 is 6,000 degrees per second. Then now do it a proportion for milliseconds. And then that will give you how many degrees in milliseconds that the crankshafts would have turned.
Okay. Next, from Peter, who's here in Calgary with me. How do I move all sparks into one bin with the GUI?
So if your sparks are firing in multiple bins, that indicates that the firing consistency is poor. That's probably caused due to excessive cushion spring travel. And that means that the vibrator spring contact is pulling away from the cushion spring contact inconsistently. So typically what you would do is you would try adjusting the cushion spring tension. Either increase it or decrease it until you improve upon the distribution, getting it down from 4 to 3 to 2 to 1. Not worrying so much about where it's firing. That you can adjust by the vibrator spring tension. But the two interact.
Okay.
I could go ahead and try to do a live demo on an adjustment if we have time and if you'd like to do that.
Well, I guess we can ask the participants that are ready to go some more. We've been going for what, an hour and a half now, Jeff?
Yeah, we're about an hour 20 or so. Yeah, sure. Anybody else want to raise their hand and ask a question live, please go ahead and do so. We've got a comment here from Anthony Chervosky. My statements on cleaning and preparing the point sets are spot on. The whole presentation is right on top of what I have done with ECT in preparation. Thank you, Mike, Tony. Fantastic. Jerry Kramer, go ahead and talk, unmute you, and we should be able to hear you.
Hello. That's.
There you go.
Oh,
Jerry Kramer.
no, I don't know.
Well, Jim, I can hear you.
You hear me? I'm still on.
Yeah. Well, let's kick Jim off here. Unless you have something to say, Jim.
Still trying to get Jerry to unmute his mic. Doesn't look like he can do it. So anybody else have any other questions? No other open questions?
Jerry, put your things in comments or in chat or Q&A. Maybe Q&A would be better.
Can you hear me now, Chris?
Yes, we
Oh,
can.
yeah, sure, no.
Okay. I'm one of those guys that always sent their coils off to let the magic happen, and I just want to tell Mike that he did an excellent job explaining the cushion spring and the vibrator and how that worked, because I had no idea. So I really liked this webinar. Thank you, Mike.
Oh, great feedback. Thank you.
And this is Larry. Can you hear me?
We can.
Yeah. Again, I want to thank Mike. I learned a lot of stuff I was only vaguely aware of in the past. So I thought that was very, very informative. Thanks again, Mike, for a great job.
Thanks for the opportunity for sharing this information. I'm hoping that it will help other people enjoy the less frustration in getting their car to run just the way they'd like.
Fantastic. So we're going to go ahead and wrap it up. If others have suggestions for other topics that would like to be covered here in these forums, I mean, we're all sitting at home on a Saturday morning at, whatever time it is in your local time zone. By the way, if you do register for these, you'll notice that an hour before they start, a link is sent out reminding you an hour before they start. So if you forget what time zone we're in, it's Pacific time, and just watch your email and you'll be able to see the reminder coming up about this. So one of the thoughts that we'd had previously was sort of a garage tour. So if anybody else would like to do that, we're open to that as well. I was thinking about some other interesting things we could possibly do, which would be, everybody's got their story about how they got their car, and I'm sure you guys all have pictures of your car. It's the most favorite thing I have to take pictures of by far, of course. And when I got my car back in 17, a couple of years ago, man, I jumped right in, and I had more problems than probably you can imagine, or not. I mean, I'm sure many people have built their cars from the ground up. Unlike me, I bought the thing and it was sort of running. and I went through 3 motors and 2 transmissions, and the kinds of problems that I had, I'm sure everybody or a lot of people can relate to, but perhaps some can't. So I thought maybe doing a 15 or 20 minute sort of pictorial of the kinds of issues that I ran into when I bought the car and how I overcame those. I got good advice. I got bad advice. Everybody's got an opinion, obviously, and it was an awful lot of fun getting the thing running and operational. I mean, I drive the car literally every day now, and it's bulletproof, knock on wood, for now, anyway, as an old car. So that's certainly a thought. If folks want to relay their stories of how they bought their car and what they've gone through with their rebuild process. I mean, you know, some folks have built body kits from the wood and tops, and oh my God, so many different things that could be covered here. And you know, what I do know about attending Model T events is that there's never a lack of stories. Okay, everybody has a story. So if you'd like to tell your story and you got a camera and some pictures, I can work with you and show you how to do this, and it'd be we could make it interesting on all kinds of levels. So please go ahead and go to the forums and make some recommendations. Let's have a conversation about this and get one ready for next week. If nobody steps forward, I'll do mine. So this is about you guys, and we're putting this together here, and I've got this platform that we can use. We had 100 people today. I'm hoping that we can get even more folks to join us on some of the future ones. As I think we mentioned earlier, we got a lot of people that didn't join. I mean, 65 people are still here today right now, so that's great. I think the board is considering using this sort of a format to deliver. Chris, help me out here. Some of the upcoming events that we're going to be live and in person, we might use this format to be able to do some things live in a webinar format for everybody to be able to participate in. Is that right?
Well, 2 things I'll mention, and Larry can pipe in here as well, but so many things have been canceled. Homecoming is one that comes up at the beginning of June, and we're talking about that. Now, we won't do the whole homecoming like from 8 in the morning till 4 in the afternoon. We're thinking of doing it in segments and doing parts of it. Second thing is they have seminars at the Vintage Garage, and we could stream those on here, as well as have physically people in there at the seminar at the Vintage Garage. So those are 2 things we're thinking of. So
that'd be good. We had a question. Where am I streaming my? There was another question here. Where am I streaming from my beautiful background? Well, I actually have a professional video setup here. I have a green screen, and so I can put anything, including my backyard. If I want to be in my backyard, I can do that. So that's what I'm doing here, and it's no trickery. This was actually on a Model T tour that I put on with just a couple of friends. We went out to Alexander Valley. I used to be a winemaker in Alexander Valley, and this is Silver Oaks Vineyard. And in the old days, I would drive my truck up to the very, very peak of this mountain. And I thought to myself, wow, I wonder if the T would make it up there. It's pretty treacherous. And man, I tell you what, going up these dirt roads to get to this peak right here, which is phenomenal. And these cars have no trouble getting up mountains, I've noticed. Even dirt roads. And this is not a very well-maintained dirt road. And the guy I was with, Brad Lusk, he's like, let's do it, man. So that's where
don't forget, Jeff, you burnt out 2 transmissions going up your hill.
Yeah, well, that's sort of what I was going to relate, how many transmissions I've actually been through and what I did to solve the problem. There's Larry. We got video on Larry.
Yeah, I finally figured it out.
It took an hour and a half, Larry.
Yeah, I had my new camera that I was using, and for some reason or other, it won't, it worked. I can see myself, but you guys can't see me. So now I got it
working now.
Yeah, I got it now.
Okay, we got to go back to question and answers, though. We still have some question and answers here. So the first one is from Anthony. He says, maybe a seminar on the E-timer and another on the I-timer. Yes, we'll take those, add those into the bucket, and we'll talk to Mike about that. So we'll get on to that. Peter would like to see a live demo by Mike right now on tuning up that coil there. Maybe you could just start that off, Mike, if you could do that.
Yeah, sure. So what I have here is I have the coil in the tester. Let's set it up for the capacitor test. And we're going to open the points, press the test button, check the capacitor. So and this says we have a little bit of leakage. It says it's good. The most important thing is the 0.47 microfarad. With the capacitor good, we press select. We go down to the coil dwell time test, and this is the stopwatch test. I'm going to press the test button to start the clock. When I release it, it starts the watch. When it fires, it displays the result. In this case, we have two dots on that, indicating 2 bins, so it fired twice, a double spark. So first thing I would do is I'd take this out, put the tester aside, and I would take a look at the points. And I wanted to see, it's a little hard for me to see from the little thing here.
I think it's too close to the camera, Mike.
Okay. I'm going to see if I can make this bigger on my screen.
Yeah, we can see it.
That's fine.
All right, so I want to first open the points and see if the cushion spring's traveling. I don't see any movement on it.
No.
So that's a problem right there. So before I spend a lot of time on it, I'm going to put the tool on here in the back, and I'm going to give it a little bit of upward. I'm going to be pushing it. I'm going to be pushing it up this way to give it a little bit of tension.
Well, you can see it's open now.
So now, okay, now at least it's traveling.
Yeah.
Oh, that's better. I can see what's going on. Let me move it. It's not really focusing, but you can see that it.
We can see it, Mike.
Oh, yeah, you
Now
can see
moving.
that.
We can see it. It looks good.
So now we'll put it back in the tester here. I don't know why it's not focusing.
You can figure that out for the next one.
Yeah, it's a little blurry. Okay, so we're gonna press it down, open the contacts, press the test button. Oops, wrong test, sorry. The capacitor we've checked already. Let's just check this. So it's now single sparking, but it's firing early. So what we want to do with that is we want to give a couple taps down here.
Well,
See how it's kind of like on the fence between the two. Little tiny taps make a big difference. So that looks pretty good.
I love how
Let's
we
go.
take a hammer to our devices here. We would never do this.
we talked about that earlier, Jeff.
Let's go to the 100 spark test, the multi-spark test, and see how consistent it fires. You can see the spark firing over here. Now, that's not, now that would be a bad coil if it did that. That's just a video. It was sparking continuously. So here it says I got good, which means that it's firing between these 2 bins, between 0 and -1. We know that it's firing, we don't know the distribution, but we know it's got to be less than 85%, because if 85% fired at 0, that would be excellent. So how do I get this bin to get onto that one? I think is one of the questions we want.
Yeah.
And so before I do that, what if it's 50-50? Okay, the software would tell you because you see the distribution. But let's just try to move the bin here, there, and that's done by the little thing here that says tap down. So let's try to get that one over by tapping down a little bit more.
Now you broke it. Oh.
You got to have a little patience. So the other thing is we could try to give it a little more cushion spring, because irregularity or inconsistency is cushion spring tension. You can tell, you can hear the tone of it change. It got a little more bassy. And in this case, we're gonna try to send it over a little bit more. Uh-oh.
Whoa.
Now you'll notice what happened is I did send it over, but now it's getting inconsistent. In all likelihood, if you put this in your car, you'd probably be just fine because it is 0 ± 1. To get it a little bit better, we want to try to increase that cushion spring tension just a little bit more, and maybe that'll condense it back into 1. I don't know if you can hear the tone, how it's changed. And we need to send them over. It gets a little monotonous, but this is the that's what you wind up doing. We'll try one more and then go on to another one.
Back to the other one. But again, we could spend some time and try to get that to come up. Let's try another one here. Go to the capacitor test to make sure the capacitor is good. Right value, good leakage, it's excellent. So we'll go on to the dwell time test. Double sparking, early again, same scenario. We're gonna look at this cushion spring, it's not moving. So we're going, if it was all the way down, we would bend this down. It has too much tension, but it's stuck at the top. It doesn't follow it. So we give it a little bit of tension. We check to make sure it's now following. Oh, I'm sorry, I didn't take a good look at that. What's the problem with this one? It's not moving, it's stuck. If you notice, it's stuck at the limit rivet.
Oh,
See
yeah.
that?
Yeah.
It's got too much tension. So I'm not gonna pry up, I'm gonna pry down. I'm gonna go this way. Now it's moving. Before it wasn't moving. Okay. All right, now we're single sparking. It's a little bit all over, but let's try to move it to the tap down. Now it's inconsistent, so we'll give it a little bit more tension. And did you notice it went that way when I gave it tension? When I got the more cushion spring tension, it sent it to the left. So I got to send it to the right by tapping down. I hope this is not generating even more questions.
Well, it has generated one. He said, should Mike be hammering that in the tester? And I said, you mentioned that before, but I'm not sure how hard you're hitting that.
Well, yeah,
Little taps are okay, but if I wanted to give it a good hit, I'll hold it here and I'll pick it up.
Right, right.
Like I'm going to give it a good whack. So I'm going to pick it up, and now I didn't transfer it to there.
Oh.
Yeah, in mine, I never whack it when it's in the case because I don't have a whole bunch of spares on hand like you do, Mike.
I went a little bit too far. That looks pretty good. Ready?
Wow.
Place your bets.
Gonna go plus.
Multi-spark.
Yeah.
Excellent. Now, what does excellent mean? 85% or more were there and less are over here. So that means, so it might have been 90% in the middle. So I can get these that fired there over there if I just pry up just a little bit. You can hear the tone. It's uncanny how the tone changed. That's going to be good. Still excellent. Ship it. And then the problem with this for perfectionists is, and you'll probably see more hands go up, you can get carried away.
Yeah.
Now I went the other way, and now it's worse because it's only good. That's pretty much. Is there any other specifics on the Q&A that they wanted to see? Bingo.
That was it.
Stop there.
Now, you'll notice that if I come back in an hour, that the metal may have relaxed a little bit. So sometimes I'll come back, you know, like the next day and just check on it.
Yeah, Matt in California says, why don't you use a tool that is not a hammer? You know, can you bend it the other way with the tool, Mike?
I don't quite understand the question. This is the tap down.
No, don't. Yeah, use get like pliers in there and move it down with pliers.
If you can get pliers in there, the tool works handy. But let me look for another thing that somebody made me. It was kind of funny. Here it is. I forgot the gentleman's name, and if he's watching, my apologies. I know your face. He said, "Have you ever seen one of these before?" And he says it's a Harbor Freight. And they're inexpensive. And look what he did. He just ground it down and he comes in here like this.
Yeah.
And then he can, anyone's coil points, he just puts it in, tightens it up like this, and here's another thing. So you can make your own pretty neat.
Brilliant.
Will that work on the bottom one though?
Yes,
No, you can't. The problem is you really can't get in there. And so
I
the other
have
thing
a
you can
pair,
get is a simple screwdriver will work in there.
I have a pair of needle nose pliers that I ground down that works on the lower one. That works pretty good.
One thing that comes in handy is this. It's from an ignition
I
set,
recognize. Is that a Craftsman?
and it's a 3/8 that comes on here. So you hold the nut, and then you can use your 7/16 to tighten this without adjusting the other nut. So you can lock it like that. So that comes in handy.
Okay, we got a couple of questions here from Brad and Jim. I unmuted you guys. Brad, why don't you go first with your question?
Hey guys, great webinar. Just one question. When, say you get your coil and it was touched on, saying you'd go back after an hour or so. Say you get one and the metal relaxes, and are you really going to notice that much of a difference in the performance of the coil? Should they, are the points really going to relax that much to notice that much of a difference?
Well, again, when it comes to, is it going to make a difference in the car? Because that's where it really matters. You have to go back and look at all the variables that are in your car. Is the timer contacts in good condition? Are the timer contacts all perfectly centered about the camshaft so that there is no error as you rotate the timer? Are the plugs all firing properly? They're clean, they're not sooted up, they have all the same gap. Is your coil box contacts all making good contact with the base contact, the side terminals? Is there any arcing going on in your coil box wood? All of those things will rob from the electrical performance of the ignition. So let's say your timer is brand new, it's clean, the contacts are brand new, and they're all perfectly centered about the camshaft, so there's no error from contact to contact. Where the cylinder position is, it comes on the contact when each of the cylinders are in the exact same position. Now, if you were going to go from a good to excellent reading, or if it drifts a plus for the -1 or -2, would it make a difference? Then you might pick it up and notice that there's not running quite as smoothly as it had before. And one of the hallmarks when I'm running one of the ideal timers, which I don't have any, that takes all the variables of concentric mounting about the cam, the contact bounce, wipe, skip, contact variation, all out of the equation. So if I'm running an I timer and I'm just driving along at idle, counting the cylinders fire, it's incredibly smooth how it works. And so then, yes, then you could probably tell if there is minor variation between the coil. When I'm running my new day timer and I haven't cleaned it recently, am I going to notice the same level of difference from the coils? Probably not, but I don't have anything really, quantitative to back that up.
All right. And with that, when say you're running the iTimer, with that ±1 on the coil, what kind of difference do you usually see when, I know you say the engine's not going to run as smooth? Does that mean you're going to see power loss or something else?
Well, it's difficult to say with certainty without collecting some data on it. But what I have noticed was that when my car is not running right and I take the coils out and they're not like you see on the example here, I'll notice that the responsiveness to the throttle is not quite there. It doesn't respond quite as quickly. It takes a little bit more to rev up, and it doesn't run quite as smoothly. Does it have more power? I don't really have anything quantitative to suggest that. I've run some. I've made up the TDAS, which was in the model, the vintage Ford, written up years back, and it was a data acquisition system that would monitor engines and RPM. And I did many runs to look at the translation between coil adjustment and performance. And so it was capable of relating the two from coil adjustment to performance, but it's not something that's easily done. And sometimes there's subtle differences. So it's hard to say with certainty on what constitutes better performance on the coil adjustment. The thing I can tell you is that the seat of the pants on, and somebody alluded to this too, on how it sounds and how it feels. If you know your car and you know the responsiveness to the throttle opening and acceleration, and you have your coils adjusted for equal and consistent firing time, it's kind of easier to note from the seat of the pants, from the driver's seat, its responsiveness and acceleration.
Okay, Matt in California had an idea. He's going to show us something. So, hey, Matt, are you there?
To show the video. I'm not sure you said that.
Unfortunately, we can't hear you.
You cannot hear me?
Now we can.
That's better.
Okay. I don't know if there's a way to show the video, but basically I don't use a hammer.
Matt, you cut out.
Yeah, now the video is able to be shared.
Yeah.
Oh, and I guess I have a virtual background on. Let me get that off. Otherwise, you're not going to see anything. Sorry.
Yeah.
So the tool I made, this was actually out of a Model T frame rail. Not that I'm saying advocating people destroying frames. I think actually getting an old wrench would be better material. It's just the frame rail was destroyed anyways. So I just put the tool in here and I bend on this side and this side, either direction. And I do both sides so that I'm not bending only on one side, and I do all my adjustments back here.
That might be good if there's a side-to-side tilt to the contacts, because that's one of the things that's difficult. You know how you want the contacts to mate nice and square?
Yeah.
If it's touching in the front or the back towards the adjusting nut or away from the gap adjusting nut, you can go ahead and shim the washers. But if it's opening on the left side or the right side, you really can't do much about it. Your tool there probably can correct for that.
I don't do any hammering, so you'll see that the back on the coils is pretty high up, but the areas I do pry, I just pry on the front side, so I do all my bending on the front of that bridge, whatever you want to call it, the bridge that's connecting to the spring.
I see also there that you have an infinitely adjustable cushion spring stop. The limit rivet's been replaced with an adjustable screw.
Yeah.
And that has to be a brass screw, otherwise it could cause problems. But that's interesting, an interesting way of adjusting it. It gives additional options. As I say, I mean, obviously that there's the beauty of this webinar and everything is that folks can get to share what works well. If they found things that may not have been immediately apparent.
Well, I like your ideas as far as hammering on the rivet. Pretty straightforward. And then if it doesn't work, you can go to this method.
I wouldn't say that it was my idea. I think it's something that's been around and folks have dealt with. And so just happy to share it with it. And Mike Vaughn did a great job of documenting it in the vintage Ford. So that's one of the sources that I picked it up from.
Well, thanks so much. It's great to see at least Jeff's face. I think you only live about an hour and a half from me, so sometime I should go.
There you go. Come on up. Let's go for a tour. Yeah. Actually, there was a question. Any touring suggestions during this pandemic? I don't know. I put a mask on and I go for a drive.
With your local club.
Yeah, I was just going to say, I just put a mask on and go for a drive, you know? Yeah. But if your local club is going to be organizing stuff, then that's going to be the best way to do it. I know that I just saw the Washington tour just got canceled, which is kind of a bummer.
Jeff, is there any way to capture the comments? Because there might be questions I could try to answer in email later on. I tried to copy and paste, but it doesn't let me.
Yeah, you won't be able to. I can export that, sure.
Okay, good idea, because I'm answering some of these questions as we're talking here.
Yeah, no, I'll export them all, and then we can sort of condense them, I guess, and make them available.
Yeah. Okay, I think we're ready to wrap it up.
Yeah, hour and 45 minutes, not too bad. Okay, guys, gals, stay tuned for the next one in the forums. Larry, any parting thoughts?
Oh, thanks for all your support, Chris and Jeff and Mike. You did a great job giving us a lot of great information. So I think that's going to be very helpful. Thanks a lot. And hopefully
my pleasure. Thank you for the opportunity to share the information.
Okay, with that, we're going to go ahead and say goodbye.
All right, bye.